Hello. In the following labs, you will be now studying SIMD, that is, in a simple instruction, being able to handle multiple chunks of data, SIMD. In the first part of all the assignments, you will need to transform a grayscale image into its black and white equivalent by applying a threshold algorithm. That is, if the value of the pixel is higher than the threshold, it becomes white, and if it's lower, it becomes black. Then, in the second part, you will need to take the same grayscale image and this time apply a contour extraction on the image that is trying to find a way to exacerbate some aspect of the picture. And depending on the size of the block in the algorithm, that is 3x3, 5x5 or more, you will obtain different results. You will need to implement all those algorithms in C and in SIMD using inline assembly code. That is kind of the tricky part because assembly code comes in mainly two flavors. One is the AT&T and the second one is the Intel syntax that you may have seen during the course. In the lab, we chose to work with the AT&T syntax that compiles best with the GCC compiler. So in the next few minutes of the video, we'll see together how to set up a project using the IDE Codeblocks that is implementing the GCC among all the possible compilers as the compiler for your project. So make sure that once you've installed the Codeblocks IDE, that you also have the GCC compiler toolchain installed. Let's check together how to use Codeblocks for the labs. The first thing you need to do, obviously, is to create a new project. The project you want to create will be a console application and can either be a C or C++ project. So I will just select C because I prefer that one. Just need to set its project name now, a place for it to lie in. Make sure that you selected debug configuration as well as a release configuration so that you can test both for a performance assessment and that you use the GCC GNU compiler. Once it's done, on the left panel you should see the sources and more specifically the main.c file that has been automatically generated. To make sure that your toolchain is properly working, just build the project, that is press the cog on the toolbar. You should see that you have no warning, no error whatsoever. And then by pressing the play button, you can run the code that you will see appear in a separate terminal window with the expected output, which is hello world in this case. Now let's see what happens when we try to execute the code that is in the support document that we strongly encourage you to consult so that you can better understand how to write inline SIMD code for the labs, and more specifically, how does the AT&T assembly syntax works and how it compares with the Intel syntax. Again, if you have the toolchain correctly configured, it should be no problem to just build the project. We have two small warnings that it should be no bother whatsoever. You can run it and you would reach a return 0 at the end of the execution, which is what is expected when a C program executes correctly. It would just return 0 after the execution. Now, in the inline assembly, we can't write print functions to try and check what is happening inside the code, to print addresses or values. We may want to check if anything goes wrong. So what we need to do now is to enter the debug mode of the execution in Codeblocks and try to add some windows with watches in them so that we can watch the code evolve during its execution. So the first thing we will need to do is to make sure that we add a breakpoint where we want the code to
stop and pause for a moment before we resume the execution. After adding the breakpoint, you can simply execute the program in debug mode, that is the red play button. And back into the main window, we can go into debugging window, and then disassembly, so that we can add actually the disassembly listing of our compiled code. And we can see right after the yellow little triangle here that we have all the move and move DQU into RSI, RX, RCX, and some XMM words. To navigate into this disassembly listing, we can use the next instruction and so forth, a little button in the toolbar that will help us navigate into those instructions. Now, what if we want to see what is actually inside those registers? Well, to do that, we can add another debugging window, which could be, for example, some watches. Watches, and not like the stopwatches. Watches are windows that help us track the values of some variables. So to add an XMM word, we need to prepend it with the $, then XMM7. And the problem is that this is a vector. This is more than just 1 byte. So we have different ways to represent these values. If we want to see what it looks like when we have 16 int8 values, that is 16 bytes, we'll unroll this one, and for the moment it's just zeros inside. This 0 repeats 16 times. Now let's progress a little bit further in the code, and after these instructions, that is move all XMM words into XMM7, we see that now this XMM register is filled with what we initiated the input vector with, that is all 42 values for the 16 byte inside the vector inside the array. Using those tools, you should be now able to successfully debug your code if the need should arise.